Hello, welcome to another edition of Momentum TV with the James Worth Bagley College of Engineering. I'm your host, Robert Green. I'm fortunate today to be joined by Dr. Reuben Burch. Dr. Burch is an associate professor in our Industrial and Systems Engineering Department. He's also Associate Director for Human Factors and Athlete Engineering at the Center for Advanced Vehicular Systems. And if that's not enough, he also holds the Jack Hatcher Chair for Engineering Entrepreneurship. Dr. Burch, welcome. Glad you could join us today.
Yeah, thanks for having me. I know that's a mouthful, so
well, a lot of titles. So, but you do a lot of good work. So I know you're a professor in industrial engineering, but I understand you got your undergraduate degree in computer engineering. Start things off. Can you tell us, how did you get interested in engineering and specifically computer engineering?
So I always knew I was an engineer. I was trying to think back to a time when maybe I didn't think I was an engineer and I couldn't place a time. My dad is an engineer. He's an electrical engineer. So around the time I was a junior in high school, he showed up in my room with about a 2,000 to 3,000 page book. And he said, "These are all the careers that you can have." And he goes, "I want you to look at these because you're going to need to get a job." You know, that makes sense. He goes, "But I've highlighted some pages for you I'd like you to consider. And they're all right in the middle and they all ended with the word engineering." And so I guess he kind of knew that I was destined to do that too. But I didn't want to be exactly like my dad as an electrical engineer, so computer engineering it was.
So you can do any career you want as long as it ends in engineering.
That's right. He was pretty strict about that.
Well, after you earned your degree here, you went out and worked in industry. What were some of the highlights of your industrial career?
You know, it's one of those careers that I probably didn't appreciate at the time when I was doing it, but I look back now and realize that it was a lot of really good opportunity. So I got to spend 2 years working on Wallops Island, which is a secret naval base where they do weapons research. I got to spend 3 years at NASA Langley doing satellite research. Got to be a manager at a young age, probably too young, but was able to enjoy doing that. So I appreciate the opportunities I had because I don't think I was ready for them when they happened, but they gave me a lot of life skills that I'm able to use now.
Okay, and it sounds like some of that experience then led you to seek another graduate degree from Kansas State in engineering management. How did that come to be?
So as you mentioned, I was a computer engineer at first. I spent about 10 years doing that type of work, hands-on with hardware and software development. And at some point, I decided that I think I was more interested in what the human thought about the interfaces and things we were designing more so than the actual design of the interface. So I was really interested in how do you make a better product or interface, and that led me to industrial engineering. So it was more about how does the human perceive the thing we're developing, and is it usable by their standards?
Okay. So eventually you came to Mississippi State and pursued your PhD in Industrial and Systems Engineering. And I understand you did that through the online program. Can you share some good things let's just share the good things
Sure.
About the online program that you went through, and how was it? I know it can be challenging, particularly for our students who just went through COVID, where we did a lot of online learning.
Right, so all of my graduate time was spent online, both my master's and my PhD. I was working at FedEx full-time when I was getting my PhD. And I think the thing that helped me out a lot is I was able to take the coursework I was doing and immediately apply it to my job. And so again, I'm an industrial engineer, obviously, so I was super efficient with my time, so I only had to do it once and it applied to both things. But it allowed me to work on school outside of office hours, but at the same time, because it applied, every single class in industrial engineering, it can immediately impact any industry you're in. So every time I learned something new, I would take it and apply it to my job, and I'd be like, "Hey, look at this great new thing I just learned," and they would think that I came up with it. Obviously, I was just learning it in class and applying it. So it helped me to be really successful with my job and then have immediate reflection back on the content in class.
Okay. Well, I know some of our viewers may be prospective students considering an engineering career. Can you tell them a little bit about what is industrial engineering? What do industrial engineers do?
I'll give you the definition that I made up. I teach the lean course, which means I get all the freshmen, so I get to make up things that I tell them. But instead of the long drawn out definition, I'd say most people are familiar with mechanical engineers. Mechanical engineers make things. Industrial engineers make things usable. or maybe you're familiar with biomedical engineers. So biomedical engineers study the human system, industrial engineers study humans within systems. So that's kind of a great way to break down how we differentiate from the other engineering disciplines.
What advice would you give a student who's maybe looking at graduate school? What are the advantages? Would you recommend them to do a PhD? What sort of doors would that open for them?
I think it's one of those typical engineering answers of it depends. It really depends where you work. There are some places where they may not want you to get a PhD. They may want you to spend more time out in the field, or maybe they want you to get a second master's. If you're looking to really dig deep into things like optimization, data analytics, or maybe take deeper steps into human factors and ergonomics where you really need to dig in and get into the weeds and the details, or if you have a job that really expects you to do some level of research. There's just something to be said about doing research in a lab in a controlled environment, and then how that relates outside to the real world.
Yeah. So I notice another title of yours is the Jack Hatcher Chair for Engineering Entrepreneurship. Can you tell us a little bit about the Engineering Entrepreneurship program we have?
So this program is hosted out of the Entrepreneurship Center and the Business School, kind of co-hosted between engineering and the business school, and it's specifically for engineers who see a future of maybe inventing new things. They know they want to be problem solvers that results in new products, new services, new software. Maybe it's engineers who want to be their own boss one day. They like the idea of having a startup. Maybe they want to be their own boss, and that's the career path that they want to take, or maybe they even want to work for a startup and not necessarily run it. So there's so many new startups and new inventions coming out every day because technology advances so fast. It's easy to have an idea that can really set you apart.
Well, you mentioned some inventions. I understand you have a couple of patents and have been involved some in intellectual property. Tell us a little bit about that. How does it feel to go through and actually have something patented?
Well, it's a completely different process than anything else. It takes a lot of work. Sometimes it can take years and years. Sometimes it can be a really quick process. A patent is all about the design of an idea. A lot of people have great ideas. The difference is, how do you design an idea so that it's unique and so that you can document it and protect it? So we've started teaching an intellectual property and patent design course that we do with the School of Ag. So we try to walk them through the process of, it has to be more than just a neat idea that you dreamed up. You have to insert yourself and become an expert and be able to explain exactly how this new device or software or product would work. So I think it caused me to work with attorneys a lot, and they speak a different language, but because you learn that language, you're better able to create a product that has more impact on who the user base would be.
Yeah. And it also has to be useful. So there goes another thing. I've got great ideas, but they're not very useful.
That's right. You want someone to want to pay for it.
Right, right. So tell us a little bit about this athlete engineering program that you've gotten started. I know we're offering a certificate or an endorsement in that now. And maybe start with defining what your definition of an athlete is.
So my definition of an athlete is anyone who does repetitive type tasks or training to continually improve and get better over time. So most people think about the sports athlete. Obviously, a lot of us, especially here in the South, are interested in that. But you also have the industrial athlete, which would be repetitive motion tasks. Someone who trains to do the same task repeatedly over and over again. You have the tactical athlete, which would be like your military or war fighter or emergency responder. The at-risk athlete, someone who's maybe having to go through telehealth or rehab or prehabilitation. Someone, again, constantly training, executing that same task, looking to improve and get better would be my definition of an athlete.
Okay. And I know a lot of what the work you do is involving putting wearable sensors on people to measure. Can you tell us some sort of about the details, the specifics of what you're doing, how you're going about conducting the research?
So wearable sensors can be anything that you put directly on the person, or you embed in their clothing or in their uniform. And you're typically looking to collect one of two things: some type of biomedical information, like information about how they move or physiological information. So the internals, the heart rate variability, cognition, those types of things. So any device that capture this type of information we would consider to be a wearable. So anything that generates human performance data then gives us the information we need to make a better health and safety type decisions.
Okay. So are you working with other disciplines of engineering in the sensors, either in developing them or selecting them? And if so, which ones?
So pretty much all of them, specifically electrical and computer engineering, mechanical engineering, biomedical engineering. I don't know that there's a discipline that we don't have a student from that works on our team, but we also work with kinesiology quite a bit. They're a really critical partner, and so is fashion design and textiles, because it's not enough to prove that it works. Someone actually has to want to wear it in order for it to be a viable solution. And so you need non-engineers quite a bit to relate to normal people to get them to want to wear a wearable.
Yeah. So are you dealing with special sensors, or are you also looking at things like Apple Watch and Fitbits and data from those sources?
We do a lot of validation in some of those more commonly known wearables, but we've been funded to build our own using a unique type of sensor called a soft robotic sensor or a stretch sensor. They were originally used in robotic exoskeletons, but we've repurposed them to fit them into uniforms so that you can get motion capture at the joints and angles of whoever's wearing the wearable sensor product.
If that's an area that interests me, where would be a good place for me to go to find out some more information about it? Who could I contact?
Well, you can definitely contact me for sure. If you're a big sports fan and you happen to know our strength conditioning coaches, they're about as knowledgeable as anybody on the planet. We have some websites out there that you can go and look up more about athlete engineering for both the certificate program, the research lab, and some of the other things we offer.
What is the ultimate goal you want to achieve with your research? How would you define success?
If we could be the group that provides standardization for validation of wearables and human performance and data collection in that space, that's where I would want to live.
Okay. So it sounds like you've got a lot going on and a lot happening in the department. I'm going to ask this question, although I think I know the answer. Would you recommend students come to Mississippi State to study engineering?
Yeah, absolutely. I came here because my dad said the best engineers were coming out of Mississippi State at the time, and I'm pretty sure that's still true.
Okay. Well, Dr. Burch, I want to thank you for joining us today and all the work you're doing, both with our engineering entrepreneurs as well as the athlete engineering. I want to thank all of you for joining us. Invite you to come back next month for another episode of Momentum TV from the James Worth Bagley College of Engineering at Mississippi State University.